Good morning, students. Thank you very much, students, for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section, I am going to discuss about the NEET preparation series day 4 schedule, students, some basic concepts of chemistry. In this section, I am going to solving previous year's questions, Nana. Okay, na? So NEET, AIMS, AIPMT, these type of questions I am going to discuss, students. Okay, na? From which lesson, some basic concepts of chemistry. So, first question is, students, the number of moles of hydrogen molecules required, the number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process is equal to, here 4 options given, students. How to find this problem? See here, how to find it. We know that Haber's process ammonia preparation, correct? N2 combined with 3 moles of hydrogen produces 2 moles of ammonia, correct? 2 moles of ammonia. That means 1 mole of N2. Here question, which one is asking the number of moles of hydrogen. So hydrogen asking, and another one is required to produce 20 moles of ammonia. So hydrogen, ammonia. So in between them, only in the question they are talking about only hydrogen and ammonia. They are not at all talking about the nitrogen, students. Are you clear this one? So hydrogen and ammonia, hydrogen moles we have to find it, and ammonia number of moles given, students. So here in hydrogen and ammonia only we have to see in the equation. Okay, na? So only these two we have to see, students, hydrogen and ammonia. You don't need to think about the nitrogen. Now according to the equation, students, how many moles of hydrogen is required to produce to produce ammonia? 2 moles of ammonia, 3 moles of hydrogen is required, correct, according to the equation. But in the question what asking, to produce 20 moles of ammonia, how many moles of hydrogen is required is asking. Are you clear this one? So 3 moles of, here how to find it, 3 moles of H2 required to produce 2 moles of ammonia. Clear this one, 2 moles of ammonia, students, 2 moles of ammonia. But question is to produce 20 moles of ammonia. 20 moles of ammonia to produce how many moles of hydrogen is required is asking. So now just cross multiplication, x into 2 is equal to 20 into 3, nana. 20 into 3, how much you will get, students? 20 into 3, x is equal to 23s are 60 by 2, how much? 30. So answer is 30 moles, students. Okay, clear? So 30 moles of H2 is required to produce 20 moles of ammonia. Understood, Amma? So this is option is 30 moles. Option D is the correct one. Just you see, students, in the question what given, hydrogen, ammonia given. So you have to think about only these two. This nitrogen, you don't need to think about this. Here hydrogen and ammonia both what given, students? Moles given. Okay, na? So moles are asking. So that's according to the equation, 3 moles of H2 produces 2 moles of ammonia. 20 moles of ammonia can produce to produce 20 moles of ammonia, how many moles of hydrogen is required? Clear, students? This is the first problem. Now I am going to discuss the second problem. See, students, this is the second question. In a chemical reaction, A plus B gives rise to AB. If B is acting as a limiting reagent, then choose the correct option. We know that limiting reagent is nothing but the reactant which is completely consumed in the reaction, correct? Or if it is present in the less quantity also, we'll call it as limiting reagent, students. Okay, now so that means in the chemical reaction, A plus B gives rise to AB if B is acting as a limiting reagent. That means in this reaction mixture, B should be present in the lesser quantity because it is a limiting reagent. That's why it is present in the lesser quantity than the excess reagent. Here B is which one, students? B is acting as a limiting reagent. A is which one? Excess reagent, na? So that's why A should be more than B. Okay, na? It is limiting reagent. That's why its quantity should be less than A. So A is the excess reagent. That means A atom should be more than B atoms. See here in these options, once you check, students, A atom should be more when compared to B. Here if you take A option, B 50 atoms are there, B atom 100 atoms are there. Okay, na? But actually A atom should be more now. So this option is wrong. Now coming to the second option, A atom should be more than B atoms. See here, A atoms are more, here 100, here 200. So A atoms are less there. So it is also also wrong. Next, C option, A atoms are 50, B atoms are 30. That means A atoms are more there. So that's the C option is correct. D option is 50 atoms are there, A, B atoms more there. So this is also wrong. So what is the option correct, students? Which is the correct one? C option is correct. Understood this one? Okay, Nama. So in this question, limiting reagent means which is completely consumed in the reaction or which is present in the lesser quantity. We'll call it as smaller quantity. We'll call it as limiting reagent. So B limiting reagent means A is the excess reagent. So here in this reaction, A atoms should be more than the B atoms because it is present in the less quantity. Limiting reagent. Okay. Now coming to the third question, see students, what is the third question? Third question, the density of 2 molar aqueous solution of NaOH is 1.28 grams per centimeter cube. The molality of the solution is, here molecular mass also given, 4 options given. So here what we have to find it, students? Molality of the solution we have to find. Molality. So how to find it? Molality, it is represented by small m is equal to weight by gram molecular weight into 1000 by weight of the solvent. Correct? It is the weight of the solvent. This is the weight of the solute. This is the gram molecular weight of the solute, students. Clear this one? So this is the weight of the solvent. Now weight of the solute to gram molecular weight of the solute. Weight of the solute means solute is which one, students? NaOH. Okay, NaOH. See here, aqueous solution of NaOH is, the density of aqueous solution of NaOH is how much given? 1.28 grams per centimeter cube given. So because we want here weight of the solute, here first I am going to calculate the mass of the solution. I am going to calculate, students, because density given, density of the solution given. From this value I am going to calculate the weight of the solution. Are you following? So weight of the solution, if I calculate it, then I can find the solute mass and solvent mass also I can find. See students, here solution, which one I am going to find? Solution mass I am going to calculate. Okay, now so mass of the solution or weight of the solution. Okay, so what we can write, students? Mass of the solution. Mass of the solution is equal to what we can write, students? Because we know that density is equal to mass by volume. Correct? Density is equal to mass by volume. Mass of the solution is equal to density into volume. So density is how much, students? Density how much given? 1.28 given. Volume is how much, students? Volume is how much? Here centimeter cube given. That means 1000. Okay, now so here 1000 we have to multiply volume. Understanding, students? Here 1.28 grams per centimeter cube given. So that is volume of the solution. Okay, now volume of the solution how much given? 1000 ml given. So centimeter cube is nothing but 1000 milliliters. So 1000 we have to multiply. So 1.28 into 1000, how much, students? 1280 grams. So this is the mass of the solution. So this is the mass of the solution, students. Mass of the solution we calculated. Next one, but we want here, this is the mass of the solute. Correct? Mass of the solution calculated. What is the mass of the solute, students? Here mass of the solute, how to find it? Here 2 molar given. What is the mass of the solute? Mass of the solute. Now see, students, solution completed. Now I am going to calculate the mass of the solute. Mass of the solute is equal to, formula what, students? Here number of moles is equal to, we know that number of moles is equal to weight by gram molecular weight. Correct? Number of moles is equal to weight by gram molecular weight. Then mass of the solute is equal to what we can write? N into gram molecular weight. Correct? Na? N into gram molecular weight of the solute. So number of moles of the solute, how much, students? Here number of moles here given 2 molar given. So 2 moles given. Correct? It is the 2 moles into gram molecular weight. What is the gram molecular weight of the solute? NaOH. What is the gram molecular weight of solute, students? NaOH given. So sodium hydroxide at molecular weight is how much, Nana? 40, na? So sodium 23, oxygen 16, and hydrogen 1, total 40. So this is 40. How much, students? 80 grams. This is the mass of the solute. Clear this one? So mass of the solute is equal to, what is the formula, students? Mass of the solute is equal to N is equal to number of moles is equal to weight by gram molecular weight. Mass of the solute is equal to number of moles into gram molecular weight of the solute. So number of moles means 2 moles given. Here 2 into gram molecular weight of the solute 40. Here mass of the solute completed. Now I am going to calculate the mass of the solvent, because in the formula mass of the solvent also we have to find. Okay, now in this formula W is there. That is it is the solvent weight. Correct? Solvent weight also I have to find. So that's why to calculate the mass of the solvent, mass of the solvent, how to get, students? Solution mass minus solute mass. Correct? Solution mass how much given? So mass of the solution, mass of the solution minus mass of the solute. Correct? So mass of the solute, how much, students? Mass of the solution is equal to 1280 grams. Mass of the solute is equal to 80 grams. So how much, students? 1280 minus 80 means 1200 grams. Clear this one? So this is the mass of the solvent. Clear? So mass of the solvent. So mass of the solution we calculated, mass of the solute calculated, mass of the solvent calculated. But in the formula molality, weight of the solute to weight of the solvent, only both are required. Okay, the weight of the solution we don't want, but to calculate the weight of the solvent we calculated weight of the solution, students. Okay, now these values here substitute. What is the formula? M is equal to molality is equal to weight by gram molecular weight into weight by gram molecular weight into 1000 by W. Weight of the solvent. Weight of the solute, how much, students? How much we calculated? 80 grams. So 80 by gram molecular weight of the solute. How much, Nana? 40. Gram molecular weight of the solute 40 into 1000 by weight of the solvent. What is the weight of the solvent, students? How much we calculated? 1200. So here you take 1200. Understood, Amma? So 80 by 40 into 80 is the weight of the solute, 80 by gram molecular weight of the solute 40 into 1000 by 1200. This how many times, students? 2 times. This is M. M is equal to this one, 2 zeros cancel. That means 2 into 10 by 12. 2 into 10 by 12. How much, students? This one? 2 into 10 by 12. 2 into 10 divided by 12. So answer is 1.66. 1.66. Clear this one? So this is the molality of the, this is the which one, students? Molality of the solution we calculated 1.66. It is approximately equal to 1.67 moles. Understanding, students? So this is the option correct. Understood, Amma? So here solution density given, students. From the solution density we calculated the mass of the solution, and here 2 moles given. So from this we calculated mass of the solute. Okay, the mass of the solute we calculated, and after that mass of the solvent we calculated. So molality is equal to weight by gram molecular weight into 1000 by weight of the solvent. So weight of the solute, this is the weight of the solvent calculated. This is the answer, students. Now next to fourth question, see, Nana, what is the fourth question? How to find it? See here. Fourth question. So calculate the molarity of 63% W by W. This is the weight percentage HNO3 solution if density is 1.4 gram per mole given. Density this one given. Okay, now. So this is the density of the solution given, students. Density of the solution. Now see molarity. Calculate the molarity is asking. How to find it, students? Solution. Molarity we should find. So molarity is equal to weight by gram molecular weight into 1000 by volume. Okay, the volume of the solution. So to calculate the volume of the solution, density given, students. So here density is equal to, we know that mass by volume formula. So from this volume is equal to what we can write, students? Mass by density. Correct? So mass is equal to how much given, students? Mass by volume is, volume we have to find it. So volume is equal to mass by density. Mass is nothing but mass of the solution, and D is the density of the solution. What is the mass of the solution? Here what given, students? The weight by weight given. So that means 63% weight by weight means, what is the meaning of this one? 63% weight by weight. What is the weight percentage? Mass of the solute by mass of the solution into 100. Correct? Mass of the solute by mass of the solution. And 63% means, what is the meaning, students? 63%. 63% means 63 grams of HNO3 present in, okay, it is present in the present in 100 grams of the solution. Clear this one, 100 grams of the solution. Understanding? So 63% means 63 grams of HNO3, it is present in 100 grams of the solution, students. So solution mass how much, Nana? 100 grams. Clear this one. So both are W by W, both are weight, mass by mass, na? So that's a 63 grams of HNO3 present in 100, 63% kada. So it is the 63 grams HNO3 solute mass, and 100 grams it is present in the 100 grams of the solution, students. Clear, Nana? So solution mass how much given? 100 grams given. So 100 mass of the solution by density. Density of the solution how much, students? 1.4 given. So 100 by 1.4. How much, students? 100 by 1.4. 100 divided by 1.4. So how much, students? 71.42 given. 42 got. So this volume of the solution, so this is the weight by gram molecular weight. Weight of the solute, how much, students? Solute weight is equal to 63 grams, correct? 63 grams of HNO3. So that is the weight of the solute. Gram molecular weight of HNO3 we can calculate, and 1000 by volume. Volume also we calculated. Now calculate molarity. Weight is equal to how much, students? Weight of the solute. So W is equal to how much? 63 grams. Clear this one? This is the meaning. 63 grams weight by weight means 63 grams of HNO3. This is which one, students? Solute. Okay, na? It is present in the 100 grams of the solution. So solute weight how much given? 63 grams by gram molecular weight of the solute. So gram molecular weight we have to find it. So what is the gram molecular weight, students? Gram molecular weight of HNO3. How to find it? Hydrogen 1, nitrogen 14, 3 oxygens are there, 3 into 16, no? That is 48. How much, students? That is 63 value. Okay, now this is a gram molecular weight of HNO3. So write here 63 by weight over gram molecular weight is 63. Okay, into 1000 by volume. Volume of the solution how much, students? 71.42. How much, students? This one how to find it? This 63 will get cancelled, and M is equal to 1000 by 71.42. How much, Nana? 1000 by, so 1000 divided by 71.42. Okay, so how much, students? 14 answer. So how much, Nana? 14 moles. So this is the answer. See here which option is correct, students? 14, 12, 10, 8. So 14 moles are 14 moles correct, Nana. Understood, students? 63% means 63 grams of the solute HNO3 present in the, it is present in the 100 grams of the solution percent, na? So that's a 100 grams of the solution. Solution mass we know that, density given, so we can calculate the volume of the solution. So after calculated volume, here we can find the molarity. And next, see, students, and one more model, different model. A mixture of 2.3 grams of formic acid and 4.5 grams of oxalic acid is treated with concentrated sulfuric acid. The evolved gaseous mixture is passed through KOH pellets. Weight of the remaining product as STP will be. Here they are asking a mixture of 2.3 grams of formic acid given and 4.5 grams of oxalic acid. It is treated with concentrated sulfuric acid. The evolved gaseous mixture is passed through the KOH pellets. Okay, weight of the remaining product is asking, students. So first of all, formic acid, when it is treated with sulfuric acid, what are the products? And oxalic acid, when treated with concentrated sulfuric acid, what are the products formed? Okay, now first I am going to calculate the number of moles, students. See here, first one, solution. So formic acid, HCOOH. Okay, now this is the formic acid, Nana. So formic acid when treated with concentrated sulfuric acid. So concentrated sulfuric acid, we know that it is the dehydrating agent. It is acting as a dehydrating agent, Nana. So that means it can remove the water molecules. It can eliminate the water molecules from the compound. So it is a dehydrating agent. So in these water molecules, it is separating, students, from the formic acid. So then here what you will get, Nana? Here CO plus H2O you will get. Understanding? CO plus H2O. H2O water molecules are removed by the sulfuric acid, concentrated sulfuric acid. Here CO gas is evolved, students. Okay, now see students, formic acid, how many grams given? 2.3 grams given, correct? First I am going to calculate the initial number of moles. So initial number of moles, Ni, understanding students, Ni, initial number of moles is equal to HCOOH. What is the number of moles formula, students? Number of moles is equal to weight by gram molecular weight, correct? Weight by gram molecular weight. So initial number of moles is equal to weight, how much given? Formic acid 2.3 grams given, 2.3 by what is the gram molecular weight of formic acid, students? What is the gram molecular weight? Gram molecular weight of formic acid. Okay, calculate, students. 2 hydrogens 2, 1 carbon 12, 2 oxygens, so how much, nana? 2 oxygens 32, total 46. Clear this one? So how much, students? Total 46. Okay, correct. So 2.3 by 46. Now see students, 2.3 by 46. Okay, 2.3 by 46. How much, nana? 2.3 by 46, it is equal to 2.3, 1 by 20. Correct? So that means initial number of moles of formic acid is 1 by 20. Clear? This is 1. 23 by 46 into 10 we can write. 23, 46 2 times into 10, 1 by 20. It is the initial number of moles of it is the initial number of moles of formic acid, and initially products number of moles, nana, 0. Correct? This one CO and water 0 we are taking. Now this final number of moles, if I take formic acid, this one it will become 0, this will become 1 by 20. This initial 1 by 20, na, it is completely converted into product, correct? 1 by 20, 1 by 20. These are the final number of moles, correct? Final number of moles of CO and water, and final number of moles of formic acid, how much, students? Formic acid, this is 1 by 20 minus 1 by 20, how much you will get? Initial minus final you have to do, you will get 0. This is the 0. Understood, amma? So this one completed. Next I am going to calculate the which one, students? Oxalic acid. Okay, now oxalic acid reaction I am taking. Now see students, oxalic acid formula H2C2O4, when it is treated with concentrated sulfuric acid. Okay, concentrated sulfuric acid, it is a dehydrating agent. It can remove the water molecules. So here what are the products, students? Products CO plus CO2 plus H2O. 3 products you will get. So here water molecules removed, and here in the product what is the gaseous mixture? CO and CO2. Okay, nama? So here CO is formed, here gaseous mixture is CO and CO2 is formed. Okay, now here these are the this is the final number of moles, students. Final number of moles, these are the initial number of moles calculated. Like that only here also you calculate initial number of moles. Initial number of moles, how much, students? Oxalic acid weight by gram molecular weight. Weight how much given? 4.5 grams given. So that's why 4.5 by what is the gram molecular weight of oxalic acid? Gram molecular weight how much, nana? H2C2O4 gram molecular weight. How much, students? 2 hydrogens 2 carbons 24, 4 oxygens 64, correct? Okay, na? Then how much, nana? 8, 10, 7, 8, 90. Okay, 90 you got value. So by 90, 4.5 by 90 means how much, students? It is 1 by 20 initial number of moles of oxalic acid. So initial number of moles of these products, nana, 0, 0, 0. And final number of moles, how much, students? This one is increased by 1 by 20. This initial will become it is completely decreased. It will become 1 by 20. That means the products concentration will become 1 by 20. This concentration is decreases, this concentration increases, na? So 1 by 20, 1 by 20. This number of moles, how much, students? This is initial, so 1 by 20 minus final is 1 by 20. Here how much, students? This is the final number of moles of oxalic acid is 0. Clear this one, 1 by 20, 1 by 20, 1 by 20. So number of moles calculated. Okay. Now see students, water molecules are completely escaped now, water molecules, because of concentrated sulfuric acid. It is acting as a dehydrating agent. It removes the water molecules. Yes. So it removes the water molecules from the compound. So here still what are there students? CO gases are there. CO, CO2. Correct? So these are the gaseous mixture. Now in the question what given? The evolved gaseous mixture is passed through the KOH pellets. So this is the gaseous mixture, CO and CO2. Clear, Nana? So the water molecules are, it is absorbed by the concentrated sulfuric acid. And what is the gaseous mixture is there students here? CO. Gaseous mixture is CO and CO2. Correct? This mixture is formed. Okay, now this mixture, the gaseous mixture is passed through the KOH pellets. So when this gaseous mixture passes through the KOH pellets, students, only CO2 gas is absorbed. Okay, now CO2 gas. So that means here when passed gaseous mixture through the gaseous mixture passes through the KOH pellets, students. Okay, they can absorb only CO2. Clear this one. KOH pellets, they can absorb CO2, students. So CO2 is absorbed by the KOH pellets. And what is the left, students? What is the, and which gas is left, students? Here CO gas is left. So here CO is there. Correct, Nama? Here CO, here CO. CO2 is completely absorbed by the KOH and CO is there. So first I am going to calculate the total number of moles of CO. Are you following? Total number of moles of CO I am going to calculate. So first of all, moles of CO left. So moles of, how many moles of CO left, students? Moles of CO left. How many moles? CO here 1 by 20. Here how many moles? 1 by 20. So total number means 1 by 20 plus 1 by 20. How much, students? 2 by 20. Correct? 2 by 20 means how much, Nana? 1 by 10. Clear? So this is the number of moles. Number of moles of CO left. Now but question what asking, students? Weight of the remaining product asking. Weight is asking. So calculate the weight, Nana. So what is the weight, students? So weight of the CO is equal to, weight of CO is equal to what, students? Number of moles into gram molecular weight. Kada? So because number of moles is equal to weight by gram molecular weight, weight is equal to what we can write? Number of moles into gram molecular weight. So number of moles into gram molecular weight. Number of moles, how many, students, we calculated now? So 1 by 10 into gram molecular weight of CO. So CO gram molecular weight, how much, students? Gram molecular weight of CO, carbon 12, oxygen 16. Total how much, Nana? Total 28. Correct? So this is gram molecular weight is 28. 28 by 10 means how much, students? 28 by 10, 2.8. So this is the 2.8 is the mass of the CO. Okay, now it is left in the reaction mixture. Are you following? Understood, Nana, this question? So to formic acid, oxalic acid is there. So formic acid when treated with sulfuric acid is a dehydrating agent. It can remove the water molecules from the formic acid. And here product is CO and water. We calculated, because here weights given, we calculated initial number of moles, final number of moles. Here also initial, final we calculated. And these water molecules are removed, and CO, this gaseous mixture when passes through the KOH pellets, it can absorb the CO2 gas. So CO2 also it is over, and remaining, what is the remaining product? CO is there. How many total number of moles? 1 by 20. Here 1 by 20. So 1 by 20 plus 1 by 20, 1 by 10. So we calculated, here they are asking mass. So mass of the weight of the CO is equal to N into gram molecular weight, 2.8. Understanding? So what is the option, students? 2.8 is the correct answer. Okay, Namma. Now see, students, last problem, sixth problem. See, students, sixth problem. What is the mass of the precipitate precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% of NaCl solution. Understanding? So this is the question, students. What is the mass of the precipitate? Mass of the precipitate is formed when 50 ml of 16.9% solution of silver nitrate is mixed. Okay, now it is mixed with 50 ml of 5.8% given. So 16.9% of the solution of AgNO3 is nothing but what, students? It means 16.9 grams of AgNO3, it is present in 100 ml of the solution. Are you following? It is present in 100 ml of the solution. So that means, but here in the question what given, students? 50 ml given. So here see what I'm saying. 16.9%. 16.9% of the what is the solution, students? 16.9%. 16.9% of the solution means what is the meaning? Solution of silver nitrate. What is the meaning, students? 16.9 grams of AgNO3, it is present in 100 ml of the solution. Clear this one, 100 ml of the solution. But in the question, how much given, students? 50 ml of 50 ml given. So found when 50 ml of 16.9% solution of AgNO3. So that means in the question 50 ml given, but here 16.9 grams of AgNO3 is present in 100 ml of the solution. It is equal to, here what we can write, students? In 50 ml we have to find. In 50 ml how many grams of silver nitrate? That means half kada. So in 50 ml means in this half how much, Nana? 16.9 by 2 means 8.45 you will get. So 8.45 grams of AgNO3. Okay, 8.45 grams of AgNO3, it is present in 50 ml of solution. Clear this one, 50 ml of solution. Okay. Now see, students, as it is here also 5.8% of NaCl solution. What is this meaning, students? NaCl is present in, that means 5.8% means what, students? 5 point, what is NaCl? What is this meaning? 5.8 grams of NaCl is present in 100 ml of the solution. Okay, na solution. It is equal to, but in the question what given? It is mixed with 50 ml of NaCl solution, means 50 ml of solution is asking. So that's why in 50 ml means in this half, that means 5.8 half, how much, students? In 5.8, 2.9. So 2.9 grams of NaCl is present in 50 ml of the solution. Clear this one, 50 ml of the solution. Understood, Amma? Okay, now see question. So 50 ml of AgNO3, 50 ml of AgNO3, that means AgNO3 when combined with NaCl produces AgCl and sodium nitrate is formed. Clear? Sodium nitrate. First initial number of moles, if I calculate Ni, initial number of moles, how much, students? AgNO3 weight how much, Nana? 8.45 grams. So here number of moles means 8.45 by gram molecular weight of AgNO3. How much, students? Gram molecular weight of AgNO3 170, Nana. See here how to find it. Here I am going to calculate. See here, AgNO3 molecular weight. Ag how much, Nana? Silver 108, nitrogen 14, 3 oxygens 48. So total how much, Nana? 170. So by 170, 8.45 by 170. 8.45 by 170 is equal to how much, students? 8.45 divided by 170 is equal to how much? 0.049. 0.049 moles. Correct? Number of moles we calculated. This is initial number of moles. Okay, now. So, and as it is NaCl also you have to find it. NaCl how much, students? 2.9 weight by gram molecular weight of NaCl, sodium 23. Chlorine how much, Nana? chlorine 35.5, correct? So sodium is 23, chlorine 35.5, total 58.5, correct? So here how much students? 2.9 this weight, okay, because here they given 50 ml kada, so that's why I am taking 2.9 weight. So 2.9 by 50, 2.9 by 50 is nothing, 58.5 number, sorry, molecular weight is 58.5. Okay, so 2.9 by 58.5, 2.9 divided by 58.5 students, how much? 0.049. This also 0.049. What about products initial concentration students? Number of moles 0 0 is okay. Initially a products number of moles 0, finally how much students? This number of moles increased by 0.049 and this number of moles decreases to 0 0, correct? This one decreases. These are the final number of moles, NF. Clear this one? 0.049 by 49, 0.049 minus 0.049, correct? So like that you will do, you have to do 0, this also 0, final concentration. Clear? Number of moles. So this number of moles initial final completed. Now what is the question students? What is asking? What is the mass of the precipitate formed? What is the mass of the precipitate is formed is asking question. So mass of the precipitate you have to find it students. What is the mass students? Here precipitate is silver chloride na? So silver chloride precipitate mass you have to find it. So what is the mass students? So here mass of the silver chloride you have to find number of moles into gram molecular weight, correct? So number of moles, how much students? Silver chloride 0.049 into gram molecular weight of the silver chloride, how much? Silver chloride gram molecular weight how much? Nanna? Silver 108, chlorine 35.5, how much Nanna? 143.5. So 143.5, how much you will get? 0.049 into 143.5, how much students? 7.1 gram. Okay, Nama, this is the mass of the NaCl. Understood students? So this is the option 7 grams. Clear? So this option is correct. It is nearer to 7 grams. Okay, understood students? Okay, I hope you like this video students. If you like this video, please like, share, comment and subscribe my channel Nana. Thank you very much students.